Good morning, welcome. This is AP Stats. Let's take a look at the interpretation. Who has an interpretation of this p-value of 0.0548 in the context of an alternate hypothesis that the true proportion of dogs who bite people is actually less than 0.25? Who'd like to give this a whirl? Yes, Brittany, go ahead.
The probability is 0.0548.
So for those listening at home, so far Brittany has said the probability is 0.0548 that we
observe the rate of dogs who bite people of 16 or lower.
Or lower, yes.
Due to only natural sampling variation.
Yeah, so let's say due to natural sampling variation alone. But what you said was the gist of it, due to natural sampling variation alone. I'm still listening.
Something with sample sizes.
Yeah, and since they didn't give the sample size, you can just say in samples of the same size.
Okay, in samples of the same size.
Samples of the same size. Okay, keep going.
Given that the true proportion of dogs who bite people is 0.25.
Given, so here's the slash in, given is the vertical bar. Given that the true proportion of dogs who bite people is 0.25. Okay, so that might be mistaken. It could be that, I mean, for example, since, by the way, this is the thinking that procedure conclusion. Okay, now I know what the probability is. That's probability of what we observe, given that the null hypothesis is true, is low, but not less than 0.05. So I'm okay with believing that, so I'm going to fail to reject the null hypothesis. I would say, well, since the next sentence would be the one that you actually write in the conclusion would be that since the p-value of 0.0548 is less than the alpha level of 0.05, we fail to reject the null hypothesis. There is insufficient evidence to conclude that the true proportion of dogs bite people is less than 0.05. And then the clickbait sentence would be, it looks like conventional wisdom about 25% of dogs bite people is correct. It looks like it's correct. But that could be an incorrect conclusion. And so a type 1 error, by definition, has a probability alpha. Type 1 error is alpha. It's the probability of incorrectly rejecting the null hypothesis. A type 1 error, by definition, is incorrectly rejecting the null hypothesis. And alpha, where you set the limbo bar, is actually the probability of a type 1 error. Alpha is the probability of incorrectly rejecting the null hypothesis. A type 2 error, which is represented in AP Stats and in statistics in general by the Greek letter beta, lowercase beta. First two letters of the Greek alphabet are alpha, beta. That's where the word alphabet comes from. Okay, kids, time to say your alpha betas. Oh, it's alphabet. That's where it came from. Alpha beta is the probability of incorrectly failing to reject the null hypothesis. The power of a test is the probability of correctly rejecting a false null hypothesis. And the effect size is the difference between p and p sub 0 when the null hypothesis is false. Effect size shows up very rarely on the AP test. So it's a lower tier concept. We're not going to spend time with it today, but use a couple of questions here. Now, friends, power is an upper tier concept. So let's just think a little bit about power. The probability of correctly rejecting a false null hypothesis. Just so you can get a feel for what power is, think of a courtroom where there's a judge and a jury of your peers. If that system is really powerful, then when guilty people walk into the courtroom, they're gonna be sent to prison. And when non-guilty people walk in, they're not gonna be sent to prison. So, if you're correctly rejecting a false null hypothesis, then, and this power, there is a picture I'd like you to draw that ties these together. I think, let's see, explain a type 1 error in context. We'll be working with this. There's just a picture I want you to draw, and the picture is two-tiered. So I'd like you to draw two bell curves, but not on the same horizontal level. The second one, this is one way that reality can flesh out, is, see, here we have P sub 0. This is the hypothesized proportion. And suppose that the truth, which is behind a veil, is over here. Suppose the truth is over here. So it turns out that the true proportion of dogs who bite people is way bigger than 25%. This is 25%. Suppose the true proportion of dogs who bite people, dogs that bite people, is 34%. So even though this is behind the veil, here's the truth. Now what happens is we set up a somewhat arbitrary standard of where the rejection region is going to be, and this is alpha. The probability of a type 1 error is right here. And you can kind of see it. It's like, if we're assuming it's 25%, then remember, a type 1 error is the probability of incorrectly rejecting the null hypothesis. So that's actually where alpha is. Beta is right here, and power is 1 minus beta. So here you can see the power of the test. So, so I just wanted you to see a picture of where alpha, beta, and power show up in this situation. And keep in mind that incorrectly rejected. Well, we'll come back to this picture a lot. But first, I would like you to see, I'd like you to see this in the context of a few examples. Turn to problem 15, please. In which case we have some loans. Now, in this case, before lending some money, banks must decide whether they believe the applicant will repay the loan. So we're coming out of a court of law situation where it's, we're going to assume you did not murder Nicole Brown Simpson, and what was the name of the guy who also got killed that night? Ron Goldman.
Yeah.
Ron Goldman. Okay, we're going to assume you didn't kill him, but if we gather sufficient evidence, then we will conclude that you did kill him. Now, by the way, in that situation, what would a type 1 error look like? What would incorrectly rejecting the null hypothesis look like in the O.J. Simpson situation?
Wrongly convicted.
Yeah, the null hypothesis is not guilty. Rejecting the null hypothesis would be guilty. And incorrectly rejecting the null hypothesis would be, what was it you said, Noah?
I said wrongly convicted.
So it would be it would be sending the innocent to prison. Wrong. So that's what emotionally a type 1 error feels like. It's when you send the innocent to prison.
What does it look like if you Incorrectly let them go.
Okay, so let's take a look at what it looks like for a type 2 error. A type 2 error is incorrectly failing to reject the null hypothesis. So let's unpack that. The null hypothesis is not guilty. Failing to reject the null hypothesis means that what happens to the accused? They go to prison or do they go free?
They go free.
They go free. So incorrectly failing to reject the null hypothesis is letting the guilty go free. So type 1 error in the context of a court of law feels like sending the innocent to prison. That's an error. That's a big mistake. The type 2 error is incorrectly letting the guilty go free. Which error is worse? Which error is worse? Sending the innocent to prison or letting the guilty go free?
I think the innocent right here.
Sending the innocent to prison is actually, by moving the line in that diagram, you can actually express the values of your society, because notice what happens when, notice the relationship between alpha and beta. This line right here, notice that if you want to decrease the probability of a type 1 error, you're automatically increasing the probability of a type 2 error. They interact. So when alpha goes down, beta goes up. So you can set things up in a court of law, for example, to express what your values are on which one is worse, a type 1 error or a type 2 error. Well, in this society, in Western civilization, it's considered that sending the innocent to prison is the more serious error. And so there's a tendency in Western courts of law to move this bar to the right to minimize alpha, but then that increases the probability of a type 2 error, which means we're going to let more guilty people go free. If you're saying, I don't want to let guilty people go free, well, then what you're going to do is you're going to end up sending a lot of innocent people to prison. Can't have it both ways. You'll make one error or you'll make both errors, but more alpha means less beta, and less alpha means more beta. Question?
So it seems like the sum of alpha and beta is a constant. So will it be like always a certain number, or it's going to change off?
Yeah, so the question is, do alpha and beta always add to a constant? Well, in any particular combination, by the way, the effect size is the difference between P0 and P. So that's the effect size. But when it comes, in any particular situation, alpha plus beta would be constant, but I don't know of any formula for what that constant is. It varies from situation to situation. Okay, so now let's take a look at our real world example here, but we're not in a court of law. For this example, we are in a loan situation where the null hypothesis is that, which one do you think it is? Do you think we assume that people are going to pay back the loan?
No.
Or do you think we assume they're not going to pay back the loan?
They think, oh wait, let's assume they're gonna pay.
Well, yeah, so let's find out. They must decide. Loan officers assess information about the applicant, totaling points to the award. So they gather evidence. The higher the point total, any applicant with a lower point total than a certain cutoff is denied a loan. We can think this decision is a hypothesis test. Since the bank makes its profit from the interest collected on repaid loans, the null hypothesis is that the applicant will repay the loan. That feels right. It feels like in the court of law, we're going to assume you're not guilty. Here we're going to assume that people are good risks and that they're going to repay the loan. Therefore, they should get the money. Only if the person's score falls below the minimum cutoff will the bank reject and deny the loan. The system is reasonably reliable, but of course there are sometimes mistakes. When a person defaults on a loan, that is when they don't pay it back. What type of error did the bank make?
Type 1.
Tell your fellow group members whether it's type 1 or type 2 error.
Wrong.
When a person defaults on a loan, what type of error did the bank make?
这张他讲的没有在题目上。
Guys discuss it in English.
Remember that the flat was used for an actual loan check?
All right, raise your hand if you think it's a type 1 error. So I see some hands for type 1. Raise your hand if you think it's type 2. And raise your hand if, to be honest, you're just not sure. This is a little bit confusing and it's tough to navigate. Okay, so thank you for admitting that. So, friends, now, first of all, it is a type 2 error. The person was not a good credit risk and the bank failed to notice this. So sometimes the best way to sort this out is to, oh, by the way, part B was type 1. So what kind of errors, so the other one is type 1. If they miss an opportunity to make a loan to someone, he would have repaid it. The way that I sort this out in my mind, because there's several layers of concepts here, I think you'll be able to see the answer more clearly. And this is a typical AP question. They'll ask you about type 1, type 2 errors in an unfamiliar context. It probably won't be in a court of law. But write out the null hypothesis, which is, say, she will repay, is what we're going to assume. Alternate hypothesis is she will not repay. Okay, so write down what the hypotheses are, and for those of you who wrestled with part A, see if you can figure out, did they reject or fail to reject? So, when a person defaults on a loan, okay, so if they defaulted on the loan, did the bank end up rejecting the null hypothesis? Or did they fail to reject?
They failed
Failed to
reject.
Yeah, because they gave the money, so they concluded that she will repay, so they failed to reject. So that's important to write down, because once you realize they failed to reject, then in this crash and burn where there's a mistake, they say, oh, they must have incorrectly failed to reject. So when you hear that phrase going through your mind, incorrectly failed to reject, you know it's type 2. So that's how I recommend you think it through. Use words, write down both hypotheses, and write down whether it was a reject or fail to reject situation. Now let's take a look at the video clip. And we're going to take a look at a clip of the reading of the verdict from the O.J. Simpson trial. I remember where I was at this moment. It was the trial going on all summer. It was June. I was living in Mundelein at the time. And the whole world was waiting for this verdict. This was before the internet. This is when people actually watched TV. And have you ever seen a TV? They're like these big screens. Okay, now.
You're like a Promethean board you can't touch.
Okay, so I'm just gonna pause this. Let's see, for the people, how am I gonna do this for the people who are at home? Am I gonna actually point the camera at the TV? I guess so. I guess that's what's gonna happen. So I'm gonna point the camera at the TV.
Hacker, bro.
And this will be, it'll be interesting to see if this works. So, here we go. Transferring screens.
Thomas is listening right now. Yeah. You should live stream when you just realize. Thomas, if you're listening,
Facebook Live or something?
You put it on the wall line. Hacker, we miss you too. No?
Yeah, usually in this situation I pause the camera, but for some reason we're just letting it fly. Okay, so here's the verdict. See if you can figure out whether it was a type 1 or a type 2 error that occurred. That's, you know how exciting it is when you have an assignment while watching the video? Didn't they talk about that in chapel recently? So, what? It was Wesley who was analyzing. He was analyzing something. It was a comedy analysis on WA TV.
A meme?
It was meme analysis, yeah, that's right. All right, so I'm gonna show you this at the 3-minute mark. Here comes the video. This is gonna be big. Just something you might remember for days to come. So, still opening, and while that's happening, maybe I can get a better cropping on. There we go. Oh, what's all this?
There's a wide variety of reactions, and so let's take a look at the next part of our it says, in the OJ video, the lack of celebration seems to indicate a concern that some error has been made. Well, tell your fellow group members whether you think the people who are not celebrating.
Well, does he ever stop talking? Okay, so let's go back to Okay, here we go. This is the actual, I think someone was putting their video camera up to a TV, and that's how this video was made.
Elements of the OJ verdict.
Mr. Simpson, would you please stand and face the jury? Mrs. Robertson.
Superior Court of California, County of Los Angeles, in the matter of the people of the state of California versus Orenthal James Simpson, case number BA097211. We, the jury, in the above entitled action, find the defendant Orenthal James Simpson not guilty of the crime of murder in violation of Penal Code Section 187A, a felony upon Nicole Brown Simpson, a human being, as charged in count 1 of the information. Superior Court of the State of California, County of Los Angeles, in the matter of the people of the State of California versus Orenthal James Simpson. We, the jury, in the above entitled action, find the defendant Orenthal James Simpson not guilty of the crime of murder in violation of Penal Code Section 187A, a felony upon Ronald Lyle Goldman, a human being, as charged in count 2 of the information. We, the jury, in the above entitled action, further find the special circumstance that the defendant Orenthal James.
I believe that's Ron Goldman's mother. Again, this is a family that lived in the Stevenson High School District, and so that was the connection for my community.
Simpson has in this case been convicted of at least one crime of murder of the first degree and one or more crimes of murder of the first or second degree to be not true. Signed this second day of October 1995, Juror 230. Ladies and gentlemen of the jury, is this your verdict? So say you one, so say you all. Yes.
All right, this time let's watch one more video where they show some reaction. I think the video on this next one, the quality of the video is a little bit shaky. I think someone was holding a video camera up to their television back in 1995. Take a look at some of the reactions here.
We, the jury, in the above entitled action, find the defendant Orenthal James Simpson not guilty of the crime of murder in violation of Penal Code Section 187A, a felony upon Nicole Brown Simpson, a human being, as charged in count 1 of the information. Superior Court of the State of California, County of Los Angeles, in the matter of the people of the State of California versus Orenthal James Simpson. We, the jury, in the above entitled action, find the defendant Orenthal James Simpson not guilty of the crime of murder in violation of Penal Code Section 187A, a felony upon Ronald Lyle Goldman, a human being, as charged in count 2 of the information. We, the jury, in the above entitled action, further find the special circumstance that the defendant, Orenthal James Simpson, has in this case been convicted of at least one crime of murder of the first degree and one or more crimes of murder of the first or second degree to be not true. Signed this second day of October 1995, Juror 230. Ladies and gentlemen.
Okay, so it seemed like there was a wide
There was a wide variety of reactions. Okay, so now back to this.
Question.
So, yes, yeah, go ahead.
Let's say someone is watching this video at home over spring break.
Yeah.
And they take a video of this video with this video videoing the video of someone videoing the TV.
Oh my goodness.
Would that be videoception?
What?
Also, if you do,
You mean,
please
you mean
send
kind of
me-
like the movie Inception?
Yeah.
A dream within a dream within a dream, a video within, you know, how deep can it
Is
go?
this the singularity?
Is it happening now? So, go ahead and talk in your groups about whether, like, there were some people, I mean, there's a wide variety of reactions, but some people were upset, thinking that some sort of error had been made. So for the people who were upset in that particular video, go ahead and tell your fellow group members, were they concerned that a type 1 error had occurred or that a type 2 error had occurred? We're just going to pause this while you talk. Here we go. We're back. Raise your hand if you have an opinion on whether the people who were upset thought it was type 1 or type 2 error. Andrew, go ahead.
I believe the people that were upset believed they were making a type 2 error.
Okay, so raise your hand if you agree that the upset people thought a type 2 error had occurred. I'm seeing almost everyone has their hands up. Let's think through this. The null hypothesis is not guilty. What did they end up doing? Did they reject or fail to reject the null hypothesis? Class?
Fail to reject.
They failed to reject the null hypothesis. Therefore, the only possible error they could have made was a type 2 error. If it was an error, it was a type 2 error because they failed to reject. So yeah, Andrew, go ahead.
If we change the null hypothesis, or if we look at the people who were happy,
Well, they don't think an error has occurred, so you wouldn't ask them, you know, what error has occurred.
okay.
It's
But
only
would we
people who
change
are,
the null hypothesis when we look at them?
at the people who are happy?
Yeah,
No,
okay.
no, because they think that the conclusion of the jury was correct.
In these situations, do we ever switch to the null hypothesis?
Question, yeah, go ahead.
And so if the null hypothesis is not guilty, and they think that it should have been guilty, then you're rejecting the null hypothesis?
Yeah, let me just map it out here. Here's how here's how I would map it out. Let's edit that out of the video. So, so null hypothesis, not guilty, that's Western civilization's law system. So alternate hypothesis, guilty. What was the jury's verdict? The jury's verdict was not guilty. So they failed to reject the null hypothesis. And so for someone who thinks that that was incorrectly done, they've incorrectly failed to reject, then by definition, it's type 2 error. Because by definition, type 1 error is incorrectly rejecting the null hypothesis. Well, they didn't reject the null hypothesis. So no one would think type 1 error. Okay. All right. Now, let's see where we are. Second loan. You know what I'd like to do? I want to, I mean, these are some nice examples, but we are on a time schedule. And we do have an 8 just enough. I want to jump, since, I mean, these handouts, I don't know if you've noticed, but these handouts have a fair bit of conceptual overlap in them. So I want you to quiz yourself. Please take a moment to quiz yourself on the blue blanks at the top. So, ladies and gentlemen, please focus in on the new handout and fill in the blanks right up top. Then when you're done, you can look up here to see if we agree. So hopefully you have incorrectly rejected the null hypothesis, and for the type 2 error, incorrectly failing to reject. Now, there's a great opportunity to review previous concepts. You filled this in already in the OJ video. The lack of celebration seems to indicate a concern that what type of error has occurred. You've already told me that you think it's what type of error? Type 2 is correct. Now, let's take a look behind the curtain here. Suppose we have a God's eye view of a particular court system. And suppose that in a particular court system, that God has revealed the actual guilt status. So this is a theoretical problem where you get to peek behind the veil. Okay? Is there a question? Are we okay? Is there a question? Okay, so suppose that in a particular court system, there are 10 people who are actually guilty that were declared guilty, but the jury gave a verdict of guilty to 4 people who were actually not guilty. Suppose that 13 people who were guilty were declared not guilty by the jury, and 40 people who were actually not guilty were declared to be not guilty. Now, based on this particular table, what is the conclusion of a type 1 error? Please notice that a type 1 error, just like a p-value is a conditional probability, A type 1 error, alpha, is a conditional probability. It's the probability of a guilty verdict given that the person is actually not guilty. See, does that make sense? They're actually not guilty. So a guilty verdict means they rejected the null hypothesis, but it was done erroneously. So you should be able to calculate alpha based on this table. You'll need a heat gun because it's conditional probability. I'm going to press pause. I want you to try to come up with the answer. You may begin. Now, who has an answer? Maybe you're not really confident that it's correct, but at least you have an answer. Peter?
4 out of 44.
4 out of 44. Well, let's see if this makes any sense. What's the probability of getting a guilty verdict, given that we're shrinking down reality to the sub-universe where people are actually not guilty? The actual not guilty sub-universe is right here. And the probability of getting a guilty verdict, given that you're actually not guilty, is in fact 4 out of 44. Good call. So that is alpha. So how about explaining the type 1 error in the context of a problem? And type 1 error occurs here when there is, and here we have to have either sufficient or insufficient evidence that, okay. So I'd like you to take a look at, don't worry about these parenthetical statements here, but see if you can fill in the explanation of the type 1 error by tackling these 4 blanks. Okay, long story short,
Wait, where are you?
we have, oh, yeah, I actually have, yep. So there were actually a lot more blanks. Did you have, yeah, you didn't have those numbers.
No.
So I had a version of the handout that had a lot of blanks that you didn't have. And actually the thing that I'm asking you to fill in, we've already wrestled with. Like, for example, you have
it's
verbal or interpretation of a
You have
type 1
explained
error.
it. It's not even the same question.
Right, so yours is actually a little bit different, but to be honest with you, those are things we've already wrestled with. So I just want you to flip, instead of doing that, let's flip to page 2 and take a peek at what we have here. On page 2, what we have is the double bell curve diagram, which you often see in stats textbooks, but this is the one that I personally reject because it's too confusing to look at. When students try to process this diagram, which is on page 2, they often get their mind boggled. So that's why, just to let you know, I recommend seeking to understand the relationship between alpha and beta using 2 different layers, alpha, beta, power, p sub 0 and p. This is the diagram to use. So we're departing from the traditional way that this concept is depicted in stats books, and we're using the 2-layer one, which I found to be much more clear. Let's just jump right over to the next page, number 25, equal opportunity, question mark. Uh-oh, a company is sued for job discrimination because only 19% of the newly hired candidates were minorities, but 27% of all applicants were minorities. Is this strong evidence that the company's hiring practices are discriminatory? So as you can see, these concepts we're wrestling with, they're used in all sectors of society when people are seeking justice and trying to root out injustice. So, first of all, is this a one-tailed or a two-tailed test? So let's think about this. It looks like the null hypothesis here would be that the proportion that they should be hiring, well, that this 19% is okay. We'll assume that they're not discriminating, that the true proportion of people that they should be hiring is and that the alternate hypothesis, what do the critics think the alternate hypothesis should be? Do you think that they think it should be less than 0.9 or greater than 0.9?
Greater.
Looks like they think it should be greater than 0.9. So they're okay with the one-tailed test. The two-tailed test would not really be a search for injustice. So, yes, question.
You said 2 days ago that it doesn't matter whether we say greater than or equal to. Does that matter here?
Yeah, that was in the context of finding areas under bell curves.
Okay.
But that does not apply when it comes to writing alternate hypothesis. The alternate hypothesis is always going to be either greater than, less than, or does not equal. Okay? So, now here the alternate hypothesis is expressed, or the null hypothesis is expressed in words that are not discriminating, and the alternate hypothesis is that they are discriminating, but it'd be one tail as you look at it numerically. They wouldn't sue if too many minorities were hired. So, this is where we're gonna pick up after break. I think now that we've talked about alternate, or type 1 and type 2 errors, you see how to do part C on that homework thing. So, I'm not really giving you any homework over break, because my philosophy is that on break, you should take a break. So just wrap up problem 3C, bring that, and I'm not gonna be grading homework over break, so.
我他妈问了陶老师，他说你们最好春假的时候把你们说书也带着。
Let's do.
All right. Yeah, you're welcome. We'll see you. Thank you. You too.